Good morning, everyone. You're welcome to the week 2 of a software testing bootcamp organized by Quality Techies. In our last 2 classes, we did day 1 and day 2. We've been able to cover software testing fundamentals. So this week 2, we shall be having a class today and tomorrow. We'll be covering software tests in life cycles and techniques. And on the call today, I have with me a testing and quality assurance professional in the person of Olusola Ajibade. We are honored and glad to have you here, Ma. So briefly, I'll be going through our profile. Just give me some moment where I bring that up. Okay. So I have it here. So Olusola Ajibade is a senior software quality assurance engineer with experience in manual testing, API testing, test automation, and quality assurance processes across fintechs and digital products. She is passionate about mentoring aspiring tech professionals and helping beginners build successful careers in software testing. Beyond her professional role, she actively trains and shares insights on quality assurance, career growth, and technology, making complex testing concepts easy to understand. So I want you to drop your emojis while we welcome our guest speaker for today. Indeed, Olusola Ajibade is a well-experienced personnel in the field of quality assurance engineer. She has worked in so many banking organizations and fintechs. So in case after completing this training, you are very much more interested in working in fintechs and the banking environment, I want you to pay close attention for the training session today, and please prepare all your questions or bring in all your curiosity to ask her all your questions while you start working in fintechs and banking organization after completing the software testing bootcamp. So we'll welcome Olusola Ajibade. Without no further ado, let's just get right into the training. You're welcome, Olusola. Please confirm if you have a sharing right. I'll stop sharing my screen right now while you share your screen.
Okay, good afternoon, everyone. Okay, so before I proceed and before I start sharing my screen, let me just turn on my video so that you know that I'm not a ghost and you can put a face to my name. Yeah. So good afternoon once again, and I'm glad to have you all here. I'm also grateful to Quality Techies for giving me this opportunity to be on your screen. So let me share my screen. I think I have a right to share my screen now. So let me try. Just confirm that you can see my screen so that before we proceed. Okay. So our host today already gave like an highlight of how much we have done in the last 1 week, and my own aim today is to make sure that we have deliverables for today, right? We need to be able to cover the software testing fundamentals. We are looking today into software testing techniques, most especially, and software testing development lifecycle, then testing life cycle and software development life cycle. So we are going to start with software testing technique. And although we have something on our screen, right, to read through, I'm also going to be breaking this down, not just with definition, but with things that you can see or you can relate with. So while we are also looking at the screen, I want you to have an open mind, because I might also be using examples that you can relate with. I don't know if you get me. So let me also know if everyone is following along. I think the way I'm sharing screen, I might not be able to see the other end of things. All right. But you can just give me, like, somebody can just talk or mute and just say something so that I know that I'm not talking to myself and we are all ready. We are all in class.
We can hear you perfectly.
Okay, thank you. So today we are going to look at what is a software testing technique. And I'm not just going to go into of course, the definition is here, but I want us to have an open mind and look at something from the perspective of, you have a house, or you just you misplaced your key, or you want to get into an house of an uncle that is late, and you saw like a bunch of keys, that there are a lot of keys there. You have like maybe 5 bundle of keys. In each one, we have like 20. For that particular key, or that particular door, the door to the house that you want to enter, maybe the person has like ₦1 billion that's inside, and you must get in. As in, it is a must. We're talking about money here. You have to get in and get what is your right? It's your uncle. And will you stay like the whole day? You have like 20 or 30 or 40 in each bundle, and you have like 5 or 10 kids. Are you going to stay the whole day trying to search for one after the other? Or what are you going to do at that point? Can somebody please, also, this class is going to be very interactive so that all of us get our deliverables and we are able to take something out of the class. There's no point that we come to class, we talk big English, and at the end of this day, nobody is getting anything. So the aim we are here, why we are here, is to learn. I'm also learning. So please have an open mind. Let's make the class very interesting and interactive. So can somebody tell me what you are going to do in that kind of scenario? I just want to hear your view on that. Nobody say anything again. Am I the only one here? Somebody should bail me out now. But the truth, okay. I think your network. Also, when you are speaking, please let me know your name. You can start with your name. Like I said, I can't see the screen.
What you said, because network took me out, so I just
Okay.
came in now.
Your network is still really crappy, but I can still take it over again if you can hear us. So your network is still crappy. I don't know if I'm the only one or somebody else has the same view. But what I was explaining is that I said that today we are looking at software testing techniques. And I don't want to just go into the definition. I am saying that I'm putting on a situation or a scenario where you have an uncle who is late, but this uncle has left $1 million, $1 billion money inside his house. When you got there, the house are locked, the doors are locked, right? The particular door is locked, but you have bundle of keys, like 10 bundle of keys. Inside each of the bundles, you have like 20 keys there, or 30 or more, or about. And I'm asking, are you going to stay there and search, trying one after the other till you reach the 50th bundle? Or what are you going to do in that situation to make sure that you are testing, you are actually testing the door to see which one works so that you can get inside and get the money? So what are you going to do? So that's what I'm asking. I don't know if somebody can just give me an answer. I don't have to. This is a class. This is our own little community. So let me hear your view. So that I don't take so much time, I know that without you coming into testing, you will just say, oh, I would test one after the other. But when you start testing, you realize that it's not as easy as you think. You realize that there is a lot to be tested. By the time you are even done with like maybe two bundles of key, you're already stressed out. And what software testing is saying is that there are smarter ways to do things. There are smarter techniques that we have laid down to make it easy for you to generate scenarios, to generate test cases, so that when you have a scenario where you have larger or voluminary situations, you have like a technique to test them. So that's it. And so that's why we come back to the definition to say that a software testing technique is a method or approach used to design test cases and select test data so that testers can verify the software works correctly. Remember, I said that using that key to open that door, each one of them you are testing, and each of that key stands for a test data. Please let me know, is everybody with me? Do you get this part?
Yeah.
Yeah. So we are saying that it's just a smart way of you staying on. Like if I say, okay, I'm going to be sharing money for people between the ages of, let's say, 5 years old to like 100 years old. Now, I will not sit down here and start saying and write test cases and say 5 years and 6 years, verify that 5 years old are eligible for this amount, verify that. I will not sit down here. What I'm just going to be doing is to see if I can either group them, if I can either look at the boundary values or look at the stages or the transition level from one age to the other to test them. I will not sit down the whole day to say, oh, I'm going to be testing from that 5 years till 100 years. In fact, even me, I'll be tired. So that's basically what a software testing techniques are. And we have a lot of them here. We have black box testing. We have white box testing. We have experience-based testing. Sorry, let me over experience-based testing. Then let me go to the next one. So now we have black box versus white box testing. We have black box here. So black box is basically testing without a code. Here we are saying that we don't need to know how they build this thing. We don't need to know the nitty-gritty of how this house was built or what they put inside, the amount of cement, the amount of blocks, the amount of water that went into building this house. What we want to check is that, is this house solid? Is the doors, the equipment are used, are they solid? Are the things that we can do, are we, as we are entering in, are we opening the door and the handle of the door is not breaking? Are we coming in and we are opening the window and all the aluminum work is just everywhere? That's what black box testing in just everyday use. Like I tell you, I want you to open your mind in the scenarios I'm using. I'm not talking about, in the recent, I am not talking about the house. I'm talking about application. I'm talking about software. But I'm just using the house because it's everybody yes knows that at the basics is to build the house. You have sand, you have to use your aluminum, your door, you have to put your curtains, you have to put your door, you have to put, it's something that everybody knows. So that should not be a problem. So, and that's why I'm using that as something so that everybody would understand. Yeah. So, yeah, this is performed by a tester without knowledge of code or internal structure. Like I said, we don't really need to know how the development work, how it was implemented, what went into what the code was, if it was JavaScript, if it was Node.js, if it was, we don't need to know. We just know that we want to check and most of the times we call black box testing behavioral testing, kind of testing, where you want to check the behavior of the software and all. Then you can input enter at the user interface level. Yeah, because this is like we said, you're just saying the outside of the what would we call it? This the fashion house itself. You're not saying the where the work is done. where they were mixing everything. You are seeing the showroom. That's the word I'm looking for. You are seeing the showroom. So here you are looking at the clothes, or the design from the showroom, testing, oh, is this one okay? That's the UI level, that's the surface, the UI of that application. You don't know what is inside. Let's even say, okay, when you get a TV, you are not trying to dismantle that TV to see what is inside that TV that you bought. To say, oh, why is this thing? Where is it? Where is the color coming from? Where is somebody testing? I know some of us did that when we were younger, because we wanted to know what was at the back of the radio. But yeah, we are saying that we don't need to know that. What you need to just do is to take your remote, on it and see if it's working. Okay, the switch is on. You are also looking at it. Okay, can I change my stations from this place, transition to another place? You are checking at that. So those are the things that black box testing requires. And I think I've already said that it's like a behavioral closed box, opaque box testing. Then we move to white box testing. This is performed by a developer with knowledge of code structure. Yeah, they know, or they also want to know what was mixed, why everything, where the wire that connects with another wire to make the color come out, why we have like 10 color, why we have it as black and white. This is white box testing, because it requires you to know the code structure. It requires you to also know how these things were integrated with each other, and it executes and inspects the program internally, also known as structural glass box, clear box, transparent box testing. Any question at this point?
Yes.
Okay, all can you keep your question to the end? So just let me write it so that I don't
Okay.
yeah, sorry, I won't ask that again. I just want to be sure that you are following me, but just highlight it so that by the end of the class we can all take the question. Yeah. So now under black box testing technique, let me put it that way. Under black box testing technique, we have different form of testing technique. Under we have equivalence test, partitioning, we have boundary value analysis, we have transitioning, model, decision table, and other, which we are going to be looking at today. So now for equivalence partitioning, yeah, it's like I said, anything that I've categorized under black box, right? I've said that they are under the behavioral testing part, right? They evaluate both functional and non-functional aspects. These black box testing are flexible. Okay. This is what we are talking about. You're talking about black box testing techniques are flexible. They evaluate both functional requirements and non-functional aspects like performance, usability, and security. It's also called behavioral testing. I think I've talked about that. So how does this work? It says that input data is segmented into partitions or classes. No, so how, before I go into all this definition, let me just explain how equivalence partitioning works. Equivalence partitioning works with groups or classes. I explained the other time, I was trying to ask a scenario-based question about the door, the bundle of keys, and how you want to select them, how you want to test them, ensuring that you enter that house to get that money, right? And in equivalence partitioning is saying that you don't need to test every of that key. All you need is to like group them into, partition them into group, right? Or into classes. Then you can test them. So if I say that I want to give people money from 5 to 100 years, like I have said, or I have allegedly promised, because somebody should take this thing and take it out, that I want to give 5 years to 100 years of age, a certain amount of money, right? Equivalent partitioning is saying that all you need to do here is not to test 5 years, 6 years, 7 years, 8 years, and be doing that. No, that you have to be smart and just group them into, let's say, okay, is 0 to 4.9 or is 0 to 5. Then you can take 5 to that 100 years. Then you can take 100 years, or or even in between that, you can do also is 0 to 5, 5 to 30, 30 to 60, 60 to 100. In this case, when you are testing, when we are generating a test case like that, is 0 to 5 would be invalid because the rule says that you will have to start from 5. Or 0 to 4 will be invalid because the rule says the partitioning, we are grouping into class. And I've said that the classes of people I want to give, or the classes of people, or group of people I want to dash money is from this particular age group. So if I have said that, I'm just going to be smart enough to say, okay, let me just classify them or group them, and I'm doing 0 to 4 years. I will do 5 to maybe 30 years. 5 to 30 years will of course be valid test case, will be a positive test case. I will also do from 30 to maybe 60 years. It's also going to be possible. From 60 to 100 is also going to be valid and all that. Then if I take anything between 100 to maybe 110 or 130, then of course it's invalid. That way you will see that the work is lesser. Even the test cases you are writing, instead of you to write 2,000 test cases just for this 2,000 test cases just for this particular what do they call it, this particular test or this particular sharing of money, you know, by 5 groups or 5 classes, the work is done. The work is done because equivalent partitioning is telling us that, you see, all these people in the same group, they will have the same behavior, they will have the same answer, they will have the same attributes or the gifts that I want to give them, because I've already made it clear that this is my test data or this is my giving data. So I hope that is clear. So this minimizes the effort of writing numerous test cases. I've said that, while still covering every important input condition and remove redundant tests on similar data, because doing 5, 6, 7, 8, just like it be redundant, or doing 1, 2, 3, 3, 4, we are saying the same thing, but doing it the same thing. I don't know if that makes sense, and it's not even a smart way to work. So yeah, this is an example here, right? We have equivalence partitioning example, and this is like a movie booking app allows users aged 18 to 60 only. We have all of us, at least majority of us or few of us, have gone to the cinema before, or even going to the cinema. You have had to book your movie for home, or even bought a ticket. So they are saying that before you can book this movie, you're only allowed to be from age 18 to 60 only. Age 60 to 60 only. Now, this is what I'm talking about. Instead of me to be saying, okay, validate that for this user that is booking this thing is 18 years old. Validate that this user that is booking this is 19. And you now do that. You spend, in fact, that's going to take like a whole day. Partitioning is saying that, EP is saying that, group them, range them, classify them, group them, and you get your answers there. And you can see that from here, it says that if this data is greater or lesser than greater or greater than 60, it should be accepted. That is between the age of 18 and 60 years. You should be accepted. You should be able to book that movie. Then this one, if your age is greater, if your age is lesser than 18, you should not be accepted. That's invalid, number one. That is if you are lesser than 18, because it says that from 18, maybe the movie is rated 18. Let's just say that. So if you have less than 18, you cannot watch that movie. So of course, that's an invalid test. You already know that your test case will be rejected. Then if it is higher than 60, remember that it says that 60 only. So also that would be rejected. So in this kind of, in the EP settings, you just have to pick one out of it. You can try to pick anything out of all these classes or group, and then run it. Now, from here now, this on our right side hand side, from your own hand is your left hand side, right? You have age is equals to 30. What would be the answer here? So we can. So is anyone with me?
Hello.
Yes.
So for age 30, what will be our answer here?
Valid.
Okay, valid. Good. Please, when you are saying, just tell me your name so that
My
I
name
can't
is
see the other side.
Damilola.
Okay, Damilola, thank you.
Yeah.
Then age 17 is what?
Invalid.
17 too is valid.
17 is
Invalid.
okay, thank you. Even though you didn't tell me your name, thank you very much. So
Miracle.
age 61, okay, Miracle, thank you. Then age 61 would be
Invalid.
invalid. Why? So all of you that said invalid and you are said valid, why, what is the reason? Now, I want you to understand why I'm asking. I just want to be sure that you understand why we're not just saying valid or accepted or rejected. There's a reason why we are saying something is valid here on the EP level. So why did you feel that miracle, sorry, why did you feel that 17 is invalid?
Okay, because from what it's from the scenario that was given, 17 is not there. So it's from 18 to 60. So we trying to add 17, it means that it's invalid because it's not part of the requirement. So unless maybe they said 17 to 60, so 17 should now be valid.
Please, people to help me share miracle some claps there. Let me see the emoji. Don't be selfish. It can be you tomorrow. So she got it because the rule or the requirement, I even love the word the requirement, says 18 to 60. So it is overdue, over sabi for you to want to add 70 or even theft or fraud, that you want to excuse people from 17 into it. So 17 is not part of our requirement, so it's going to be invalid. And what we have just done here is to just take just a representative from here. Anyone we are taking from all these classes or group is valid. Do you understand? So we don't have to take all the whole word. Just these are example of it. Yeah, thank you for that. So let's move. So again, to just give us a clear, the host has done a very good job to just make this class very, very similar. So there's a diagram here, right? And the diagram is just telling us the approach and how we got to where we are. So also to have a broad understanding. Excuse me. Give me water, please. Give me water. So how we got this EP, the approach, and why we stood with this. So now the first diagram, you can see it from here, is just like an approach or the way it transitioned here. So is the first thing it says that we divide input range into distinct classes, groups. So let's say split age 1 to 100 into 5 segments. I've told you you can split them into 3 groups, into 3 classes. It depends on how you have that luxury or how the data or the requirement is like ambiguous. You understand? So if you have what do they call it? On 1 to 100, you can do like into 5 places. So we can do 1 to 20, you understand, 21 to 40, 41 to 50 to 60, like that. You have 5 groups or 5 groups or 5 classes that way. Then the second phase says that we select one value from each partition. So now, when we have 1 to 20, 21 to, so from 1 to 20, you can pick any number from the middle 1 to 20, just like we did earlier on, taking 17, 30, and you understand? So you can pick like that. If you pick between 1 to 20, it's still right. If you say, okay, I'm picking a 15 or I'm picking a 10. Then the next one, I'm picking from 21 to 40, I'm picking a 38. You are still right because it's still in the same classes. So whatever happened to 38 will happen to 30, will happen to 39, will happen to 40. Do you understand how this works? Please let me know if you understand this well. Then when you get to the, okay, thank you. When you get to, somebody is, okay, I'm not sure. Okay. Hello, please, can you mute so that I'm not distracted? So then each value represents the entire partition, like I've said. Every value that you take from each of the classes or group represents, so it's still the same thing that will happen to the other ones. Then example partitions for age testing ranges from 1 to 20, 21, 40. I think I've even passed where I'm supposed. So you understand, I've explained this from 1 to 20, 21, and until you get to 40 to 100 and even more than 100, because remember that whatever you are testing, you also have to test for the invalid or for the negative test. Remember that your ability as a tester is not just to test the positive scenarios. Your strength and for you to be called a great tester is in your negative testing. So always put that at the back of your mind. So then simplify test. Okay, this simplifies test cases design process, reduces the total test cases needed. Of course, when you already do this, just have like 5 instead of having 100 test cases. Just have like 5, at most maybe 6 when you had one more, or even that 5. You can even do it like three classes or group. So then this also ensures coverage across input domain. Like you realize that at the end of the day, you have covered everything in between that requirement, everything in between, because test coverage is also a thing. It's not a matter of just testing. Are you covering the entire requirement? Are you covering the entire software? Is it like you are testing one part and some other legs are still outside? So it's very important. But this approach will help you like seemingly cover all of that. So let's move. So now we move to boundary value technique. Yeah. So we call this one BVA, and also this is also a black box technique where tests are designed at the edges. So now for EP, that's equivalence partitioning, is be talking about the classes, the group, the classes, partitioning classes or groups. Here in boundary value technique, we talking about boundaries, edge. All of us talk, I respect my boundary. I don't want anything to happen. No, everybody use boundary a lot. And when we talk about boundary, it's talking about limits. It's talking about the edge of something. Like it gets to a point where you don't want people to cross, or you feel like it's a very delicate pass. You are being very careful of that place. So the same thing applies to this boundary value technique. So these values, the values that are here, we're talking about the edge boundaries of all the values that are involved in this. So you are going to be testing based on the boundary region, the edge region, like edge, I don't know how to put it. I don't have the right word to put this, but I hope you understand. You're talking about the head, the things that are like on the almost at the outer part of the requirement or of the value. Let me put it that way. So this focuses test on the boundary region, on the assumption that most defects are found right there, because it's on the boundaries. When people want to pass their boundary, like you used to say, pass boundary, when people want to take a step further aside what they have given them. You know, I was asking Miracle the other time, and she said that because they did not even tell us to do this, they told us at 18. So when you are at the edge can be from the beginning, from the lower or from the upper. It can be from the higher level or from the lower level. Do you understand? So somebody can want to do. So say some people to do. You ask them that they should do A or they should do 100. They want to put extra. Let me just put extra. Let me put extra for you don't know. This one is not accounts that will be putting miscellaneous spendings there. No. whatever requirement is given you, that's what you stick to. So now this diagram is showing us 1 and 100. And you can see from here that from that one, now this is the lower boundary. If anything from this, if this yellow circle now comes before a little bit, let's say is 0.5 or is 0 or something, then you have passed your boundary. You have passed where I've left you. Where I said that you should stay, that's not where you are staying. You have you have passed your boundary. Now, when you come to 100, you can see this cycle here, this yellow cycle here, is saying 100. Now, if you come a bit to 100.99, 100.88, 100.11, 100 you have passed your boundary. And software testing technique is saying that because we don't want you to test from 1 to 100 and all that, just look at those edges. Be careful of them. That is where the errors most times come. But that is where people want to overtake their share. That is where people want to, the bugs are usually there because that's where people want to put an extra inch. Even when they are coding, your developers, that's where they may not just pay attention at that point. They are already maybe putting like, okay, if you have to say today or 24 hours, 24 hours can start, like say, okay, from now, let's say 12 p.m. today to maybe 11 p.m. tomorrow or so, or 11:59 p.m. a.m. tomorrow. Now, a developer can feel like 12 to 12 is okay now. 12 to 12. You see that 1 second, be 1 minute, be that you have put there. You have passed your boundary. You have passed your boundary. So this test technique is telling us that pay attention here. Pay attention here, and that is where your test case will come from. So I hope you understand from there. Yeah. So let's look at this. A rule here is a bank withdrawal must be between 100 and 220,000 naira. Sorry. A bank withdrawal must be between 100 and 20,000 naira. Right? Now, what they have told us is that we don't care whatever you have, but you people should not pass your boundary. We are putting pass your boundary. People should not pass your boundary. Make sure that whatever you are doing in this life, whatever I've given to you, your transfer should not, or your withdrawal should, no matter that time that CBN was giving us like withdrawal limits. They gave us withdrawal limit at that time that you can even collect from, I think, ATM at one time. I think it was 10,000 naira. I can't remember. And you would ask me, why was it even possible for ATMs when you go to use that 10,000 they will give you? Because some people also tested. They have to test. They have to use this boundary value to put it that, okay, if you put a extra cannot come there. Extra cannot come there. Now, 100 is there. Now, 99.999 cannot come here. It's rejected. 100 we go because, like Miracle said, that's what they asked us to do. Start from 100. 101, 20,000 naira. When you get to 20,000, I want to put Jara because it's my sister. It is my uncle's cousin, brother, mommy's uncle. I want to give him more naira. It is not allowed. So even if you put 20,999, what am I even talking about? 20,100 and kinikon. The system is saying reject it. Remove them sharp, remove it. We are not going to accept it. And you can see from here that we are focusing on the boundaries, on the edge, So I hope that is clear. I hope that's clear. I hope that is clear, or you still want to use some other examples for you?
It's clear.
Okay. So now let's get back to, because we still have some other. So we have accused time. So I'm not going to answer all this one. Is it people that would answer it for me? So how are we going to move? Yeah, so let's start. I think this is the first skills 1. Yeah, we have a system has set values in the range 1 to 50 inclusive, which is the correct set of boundary value test inputs. So the range is 1 to 50. So which is the correct set of boundary value test inputs? First, what are we looking at here? What test technique are we using here? Am I alone or am I talking to myself? Oh yeah, no.
Yeah.
I said I am off mic so I can see the other side. I want to start calling people by myself.
Can you hear me?
I think we're using the black box.
Person wants to talk, but okay. Who is speaking? Who spoke the other time? I can't even. So one person is speaking. Let one person speak, please. I think is it Miracle?
Yes.
Okay, so you were saying something. Let me go back to my screen. So I first asked that what testing technique are we using in the first place here? To start with.
I said we're using the black box.
No, everything we are talking about today is black box, actually.
Okay.
So
Okay,
what type of the black box test are we using? Techniques are we using?
Okay, let me look at it.
Boundary.
Can I go on?
So somebody else can go. Yeah.
Yeah. When you're looking at the techniques using, can you hear me?
Yes, I can hear you. Please, what's the name?
It's Caroline.
Caroline, good to have you there. Okay, you can go on.
So the techniques that we're using is this boundary techniques.
Don't tell me is this. If I want to share money now and say that, you will give me complete now. You should be bold. You should be confident. You are a software tester already. So what? Don't say boundary this thing. I will not take that one.
It's the boundary techniques, the boundary value techniques that we're using.
Okay, God bless you.
And we're given the limits. I mean our boundary, the lower and the upper boundary. So we're given 1 to 50. And this thing said inclusive. That means 1 and 50 is also there.
Yes.
But if it's exclusive, that means 1 and 50 must not be there.
Mm-hmm.
So for the inclusive now, we only have B and D because 1, 25 and 50. 2, 25 and 49. They are still within the boundary of the lower and the upper boundary. So our answer is B and D. A is not there because the 0 is not there and 51 is not there. For C, we have 0 and 100, makes it invalid. For E, we have -1 is 0 and 51, makes that E invalid for this our boundary given to us. Thank you.
Okay. Does another person have some other answer?
My answer. Okay. Good afternoon. My name is Ogochukwu Kunkwo.
Okay, Ogochukwu, nice to have you here.
Yeah.
You can go
Thank
ahead.
you so much. I think my answer is B.
Okay.
Is B.
Why?
That's 125 and 50. It accepts a range of 1 to 50 inclusive. So that means anything. So obviously for A has 0, which is not part of it. That disqualifies A. C has 0, which disqualifies C. E has -1 and 0, which disqualifies E. Then okay, D2 is correct. D2 is correct because that is B and D because it has 2, 25 and 49. So it's B and D because they fall in between the boundary of from 1 to 50. So we have B and D. Thank you, ma'am.
Okay, thank you very much. So another person wants to go again, or should I?
Yes. Good afternoon.
Okay.
My name is Michael. So the answer is A.
Michael.
The answer is A. So, the upper and the lower boundary is 1 and 50. So it needs to take that into consideration. Then it needs to test just below the lower boundary, which is 0. It needs to take that into consideration. It needs to test just above the upper boundary, which is 51. It needs to take that into consideration. Then it needs to test in between. It needs to test 2, just a little above the lower boundary, which is 2. And you need to test just a little below the upper boundary, which is 49. So the answer is A.
Okay. Yeah.
Thank you, everyone. So there are still other questions though that we will still answer. Okay, yeah. Last person is on this, so that
I will go
we
with
still have time for more questions.
this
So don't worry.
talking.
Yeah.
Can you hear me?
Yes, I can hear you, please.
Okay, I'll be going with B.
Please say your name so that when I want to, I can.
I said Theophilus.
Okay, Theophilus. Okay, nice to have you.
Thank you. So I'll be going with B because the question says a system accepts values in the range of 1. There must be 1 to 50, and there must be 50 inclusive. So B is the right answer for me because 1 and 50, you must test them. It's compulsory. You must test between 1 and 50. So if you are going with D, there's no 1 inclusive, there's no 50 inclusive. So B is my final answer. Thank you.
Okay, thank you, Theophilus. So thank you, everyone. All of you made your points, and I appreciate it. But now, the person that got the answer is Michael. I don't know if I'm correct. The person that took A as an answer. Yes, even though all of you got it because they said it is 1 to 50 inclusive. But don't always forget. I said it earlier, like when I was saying something, that the main essence of you being a tester is not, your power is not in your positive test. If the require says, oh, test if this key can open the door, and you only take this key to open that door, you have only done the positive test. You have not done the negative test. You have not done that thing that you are a tester to break the application. Not only, yes, you are here, 2 things. You are here to check if the requirement meets the standard, if it is correct, if it's working the way what it should be. But also, you are also testing to break the application. And if you are testing to break the application, you cannot always do the good thing. You can always do the happy part. You cannot always do what is there. That is error number 1 that made most of you, the ones that took B most especially. Because yes, it's inclusive. You feel that, oh, it is 1 to 50 inclusive. Because they said inclusive, so you just 1 to 50. What happened? Remember that I said that where you will get your bugs and where you will get your error most of the times lies in the edge, in when you are passing your boundaries, in when you are doing over sabi, I too do, is my uncle's sister, is my friend, let me put one jara, let me just sum it up. Those edges are where and you are here to break the app in the first place. So A is the answer. So let's dissect it. A will give you is 0, is the edge, is you don't pass your the place they ask you to start. You don't extend them. They say make you start from 1 to 50. 1 to 50, they say inclusive all of everything that is in there, right? You don't start from a 0. They did not ask you to start from a 0. They said 1. So that's the way we think. Is 0, that's the boundary. That's the boundary. That's, you don't pass that boundary that you have passed it. Then everything in between. Now, you can decide to even say 1 to 50 or 1 to 49 or 2 49 50 or just do 49 51 anyhow. But 2, the reason why 1 is where the boundary starts, the value itself starts. 2 is just like a little above the value that was given. 49, by now we have got it from 2, let's say anything 2 to 49 is still valid. Then the 50 gerege, the 50 on points, on dots. Now, where is another boundary that we have? 51. Because that is 0 and 51. Go. That's what we want to shop. That's what we want to hit. That's where our box is. Because the way we have said it, that people, that's why I'm using that word pass, because all of us is, you are passing your boundary. My boundary, I don't know. I don't like when people extend their boundaries on me. You use that word very well. It means that there's a certain things you have put people or where you have put them, and you don't want them to cross that line. The moment they cross that line, you say they have passed the boundary. And software testing is telling us that most of the times we have defects decluster in our 7 principles of testing. I don't want to take you back there. And it says that most of the errors are on the edges and on the places that those boundaries, that's where you get most of those errors. Those bugs. And we are here to find bugs, my dear brother and sister. We are also here to break application. Also, we are here to make sure that what they ask us to do is the correct thing. We are meeting the standard of what the requirement has said. I don't know if you get me that way. So what I'm saying is that the person that got it is Michael. Am I correct? Because Michael considered the positive and the negative. The inclusive that is there, it also includes the 1 to 50. It did not exempt it. Neither did he remove the negative tests. Don't forget that we are trying to coin our test cases out of these testing techniques. When they give you a work to do or an application to test, and they give you so many ambiguous numbers, test from these people, 1,000 people to 1 million people. Nobody even knows that. You first look at it and say that, where will I start thinking from? Where will I start this test from? And all that. But this black box testing techniques or these testing techniques are telling us that you don't need to stress yourself. When you use all these particular testing techniques, is a way to make you that you are able to break the app, test negative, and also meet the requirements that have been set. Like Miracle said, the require that has been given, which is 1 to 50 that they gave as requirements. You met it. You have also checked the test inputs in between. Everything is fine. Then you take 0 to 51 also, which is the negative. You're supposed to also break the app. So say that if you put this 0 with the application, take it. Will it just take? Because the system has set value in the range. If I put 0, will the system accept it, or will the system start checking, or the system reject it and say no, you go nowhere because you are 0, your number is 0, your number is 51? Does it make sense? So does it make sense? Please give my Michael his clap, or he deserves it too. Let's give him, let him. I'm going to come and watch because I know you people. Thank you everybody. I'm clapping too. Thank you, Michael. So thank you everyone that contributed. So let's go to the next question. I don't know. I think I'm running out of time. I don't know. Host, have I not? Sorry, I missed the chat. Hope I'm still in time. So the second question is this: boundary value analysis is what? Everybody should get this one.
B.
B is the answer.
B is the answer. Black box.
Okay. All of us, let's clap for ourselves. Yes, a black box test design technique. Yeah, we don't look at the code. We do only focus on the inputs and outputs. And so that's that. So let's go again. Let's move. A program requires a 4-digit PIN between 1,000 and 9,999 naira. Sorry, between 1,000 and 9,999. Yeah, that's the PIN, which represents the correct boundary values. So, which one? Okay, we have a program that requires a 4-digit PIN. Between the PIN must be between 1000, that's 4 digits, then 999, 4 digits. Which of these from A, B, C, D represent the correct boundary values?
B.
Everybody, B?
B.
B.
Thank you. And we know why now. We know the lower boundary, we know the upper boundary, and we know if we go below it, we go above it, 99 and 10,000. Yeah, so that's B. Let's move. Thank you very much, everyone. So we have a system accepts input values from 1 to 99, which is the best set of equivalence partition? We're talking about EP here. So which is the best set of equivalence partition here?
A.
Who else is talking? Please, when people are not talking and you are the only one that wants to talk, please say your name so that you can take your clap, your this thing alone.
It's A.
A. Okay, why? Can you explain?
It's because that it requires the input values between or from like 1 to 99. So we have to include 1 to 99, and then anything less than 1 is not going to be included, and anything or any values bigger than 99 are also not going to be included.
Okay. Yes, exactly. Thank you for that. Then a mobile app requires, I think this should be the last two. Okay, so you still have one more. A mobile app requires age 18 to 60 for registration, which is the correct equivalence partitioning.
It's A again.
Okay, so yeah, correct. Thank you. Please give him a very good round of applause on that. And we know why. So let's move to the next one. So we have this is the sixth one. Why are boundary values choosing for test designs?
B.
Are you all tired? There's only one person that I'm hearing their voice. So.
B is the answer.
Oh, yeah, with you. It's
Yeah?
B. B is the answer.
Okay, thank you. Thank you, everyone. You've done well. Good job. So let's move on. So yeah. So we have we're back to another form of software testing. Yeah. Hold on, please. Okay, so now we are back to another part of black box testing. So we have talked about EPE, that's equivalence partitioning. We talked about boundary value analysis, and now we are on the decision table testing. So so let's get at it. So for decision table, generally just about thinking that if this is not this, then this is this, or this is that, something like that. Yeah. So you're just decision table, you are looking at the combination of inputs of conditions and saying that, okay, if these two did not work, then this or these two should, no work. So decision table testing is used when a system behavior depends on different combination of input condition. A decision table pairs condition with the action each unique combination should trigger. So let's use what do they call it? Let's use this example now. Login requires a valid username and valid and password. Valid username and password. And now yeah, if you see it here now, you can see that from here, it's saying that username valid, yes. Password valid, yes. So what we are saying here, yes, yes, it means that when the system accepts that it is yes, yes. So if a system accepts this username, that okay, your username is correct, yes. Your password is correct, is valid, yes. Then the result that should happen is that it should be successful. You should be able to access the application. You should be able to log in into the application. Right? Am I right? You should be able to log in into that application. Now, if one of these is either wrong, this username or password, any of it is either wrong. Either the username is wrong and the password is yes, or the username is right and the password is wrong. You can see this yes, no, no, yes. It should not allow the user, the system should not allow the user to gain access, or should not allow the user to access the application. And in a situation where the two of them does not either exist or does not pass the requirement, maybe does not pass, is a wrong username or is a wrong password, the two of them, the two collabo, none of them is right, then it's also going to be error, wrong. You cannot gain access. You cannot gain access. So that's still what's going to happen there. So the decision table is just a table that helps us to test all possible combination of inputs and their expected results. All combination. In fact, this table can, I said something and I said that even if it does not exist, if the username does not exist, just say I'm going to a Facebook application now and I'm typing and I did not put my username and I still did not put my password. It's supposed to still tell me error. It's supposed to block myself out of it and say, Auntie, I don't understand what you're talking about. So you can't come inside. If the two of, even if I put something there and it's the two is wrong, it should still tell me. So what I am basically doing is testing all the combinations, the possible things that will have inputs that I might put in here that might either go wrong or go right. Right? So, and the expected result that I'm supposed to get if I trigger them. So that's basically what decision table is. So you just think like, okay, it's a rule book for decision. Like say, before this decision is taken, this must be passed. Before I can have a successful login, or before I can have a successful payment on any payment application, then I have to fulfill something. I have to fulfill that there's a cash inflow in my account. I have to fulfill that the correct, the validated number, account number and name is also there. I have to also fulfill that the amount is stated. If the amount is not stated, even if my account number is correct and is validated, and I also have cash inflow in there, will anything go? It won't go now, because you are giving the system an incomplete decision to make. It's even going to be difficult for that system to make a decision, because in the first place, you are giving me an incomplete requirement. So I don't even know where to put it. I don't know where to place it. Do you understand? So the same thing for maybe a login scenario. I'm using a login scenario because, of course, it's the common thing that basically all of us on this app have logged into something, into an application at a time or the other. So if any of your input, any of your combination of inputs is not validated or is not corrected at any point, then the decision is that it will tell the system, it will tell you that, oh, error, you're not allowed, or you can't do this, because you are not even giving the system either the right information or the right input, or you are not giving the system any information at all. And of course, if you don't put anything into this system, or you don't put the right information into the system, what do you want the system to do? The system cannot make a decision at that time. So that's what decision table, is all about. So yeah, I think this is a decision table here. And this decision table is talking about conditions here now. adding a single, sorry. So this is adding a single action to a decision table. So the condition here is married. Rule number 1 here is it says that rule number 1 here, if you are married and is yes, if you are a good student and is yes, your discount will be what? 60. If you are if you are married, yes, and it is yes, that's rule number 2. That's what the system, we have made the system to understand. If you are married here and is yes, you are a good student, you are not a good student. You are married though, but you are not a good student. We are going to reduce your discount to 25. Now, rule number 3 says that if you are married though, are you married? No, you are not married, but you are a good student. So we really do not mind, even if you are not married. So it's not something, excuse me, it's not something really bothersome for us. We are still going to give you a 50% discount. Sorry, let me take that. So we are still going to give you a 50% discount because we can still a little bit overlook that you're not married. Then we'll do 50. Then you are not married. Rule number 4. You are still not a good student. There's going to be a problem because we are not going to give you any discounts. Now, these are the rules that have been sent to the system. Now, if you fulfill, so the system is just saying that all this combination of inputs, if you have this input there, the system understands it and gives you a 60% discount immediately. If you do not, rule number 2, you are married, but you are not a good student, you don't come to class, you don't listen. When you don't read, you don't do anything. We are just going to give you 25%. The system understands the rule that have been there, and it gives you the response. It gives you the decision that has been made on that. If rule number 3, you take number 3, you are married, but you are a good student. You are not married, rather, because married is no. You are not married, but we do not mind. You are a very good student. You come to class early. You come to punctual to class. You are consistent with class. You do your class homework. You are a good student. We will still give you 50%. Then number 4 is saying that, oh, you are not married though, still yet, you are not a good student. You are not taking any discounts. In fact, 0.00 naira I'm not going to give you. Do you understand? So it's a kind of way that the combination of your input has been imputed, right? And the system understands it and give you the result to it. So this is what decision. So you're just going to take. So when you want to write your test cases, you'll be pairing these two now to say, okay, by the day that a married person and a good people, when a person is married and a person is a good student, they're able to get 60% discount. Rule number 2, validate that when a person is married but they are not a good student, they get 25%. Number 3, you like that. You have like this. You have generated like 4 or 5 test cases from this without even have to like bust your head or bust your brain and looking for test cases all around. Is that understood?
Yes.
Okay. So only one person answered though. Are we good on that?
Yes, it's understood. Yes,
Okay,
we're good. I'm good.
Yes.
Thank you. Thank you, everyone. So then we have state transition testing. Basically, this one is just talking about is thinking system changes from one state to the other. What happens when a system changes from this particular level A to level B? What happens in between that transition? What happened in between that state of transitioning? Going from single to like say married, what happens between that? Going from being maybe working in a random place to being a tech sister or telecom, what happened between that transitioning? That's what transitioning testing, state transition testing is talking about here. So, and this is when This is used when a system changes from one condition to another based on actions or events. And that's why I use those two things. It's not like necessarily talking about, I'm talking about software. Anytime I'm talking about a software, it's software because I'm just trying to use things that everybody can relate with. So no hard feelings. So this verifies how a system behaves when moving between states in response to events or condition, checking valid transitions, invalid transitions, and the expected output for each of the change, valid transition, invalid transitions, and the expected outputs for each change. Because there's also always even for invalid transition, there's always an output now, an outcome for that. You understand? So from this, what do they call it now? We are using the traffic light state diagram. We have the state is from red, it turns green. Red, we all know is stop now. Then when it says red, after some maybe 60 seconds, it moves to green. From green, it's expected to go to yellow. From yellow, it goes to red back, right? Because yellow is get ready, like you get it ready. I don't know, I've forgotten. You know, me, I did not go to all this Montessori school. I went to an evening school. There's one point they used to think about traffic light, something. Something like that. So this red to green to yellow to red now is the normal transition state. That's the way it's supposed to be. That's the valid way it's supposed to be. You are in the street of Lagos, you know that's even anywhere you are, if you have traffic light, you know that's the normal thing. It is valid. That's the way they transition from red to green to yellow to red, and we all know what they mean. Now, red to green, if we even want to take just something like a particular thing out of it, green to yellow is a good transition. Yellow to red is a good, red to green is a good transition. But now invalid is when a red is showing yellow straight. It means that after you have stopped me, you go to yellow again, you skip green, you go to yellow, or from green, you go to yellow. You know, the transition is not transitioning as you disease will talk about it. It's not going the way it should go. So it's not always skipping the green on that part or skipping the yellow in that part would not, the transition is not going well. So you are looking at what is happening at that event, at that occurrence, and you're looking at that transition level. Is it going the way it's supposed to be? Those are the things you are using to bring out your test cases. Red, green, yellow, red. You understand? Red to green, yellow to red. Now, if I take red to green is even fine. If I take green to, let's say, maybe green to yellow, of course, what I've said it still will not work because you have to, I've left yellow now. I'm on red. Why are you taking me back to yellow again? Is it like yellow, red, yellow, red, yellow, red? It makes sense. So that's this. So another example under here also talks about the phone lock screen. So the current state should be like the new state. When you locked your phone, everybody has a phone. At one time or the other, you have locked your phone. When you lock it, you want to open it. You have to put your pin, right? You have to put your pin, then unlock it. Then when you put your pin, the system understands that, oh, this is what I need. When this person put the pin, is saying that he wants to get access to this phone. So it will unlock it and you start using your phone. That is lock your correct pin, then it will unlock. Then in a case that it is invalid, we can do something like, okay, your phone is, you have unlocked and you are asking you to enter pin. Does not even make sense. That I'm there, you are still asking me to enter pin. That means you don't even have access to the first place. Now, you cannot also, if you also put the right pin, you correct pin, and you still do not have access, it's correct pin, but you still do not have access, then there's something is wrong with the system. Something is wrong with the software or with the code. So those are where you get your test cases from. So these ones happen on the state transition testing part. So are we good? We're moving. So we are on the use case testing testing technique. And on the use case testing, we talk about real user journey. How does this thing work from point A to point Z? How does this thing, okay, payments application, how does it work from the beginning to the end, to the point where the other recipient receives the money, receives the cash? You understand? So that's yeah, and most of the time this had to come derived from use cases or from user stories. Yeah. So use case test cases are derived from use case or user story, how an actor interacts with the system to reach a goal. It tests end-to-end scenarios, the main flow and the alternate flows. So let's look at this. Let's do a use case of withdrawing cash from the ATM now. Virtually all of us, because we are big guys and big ladies here. So we have plenty money and we used to use the ATM. So now, if you have to withdraw cash from the ATM, the first thing you have to go is first get to the ATM, wherever it is located. You stay there, you insert your ATM card. Of course, it will ask you for your PIN to be sure that, okay, you put in your PIN, you select withdraw, you select your withdrawal. Sometimes here can also, it can even have where it will ask you, is it from your current account or from your savings account, before you even have to select your withdraw. Then it asks you for the it's asking for the amount. Now this is just like what, sorry, I'm having this thing. Sorry. I'm having hiccups. So this thing is just like what is on. We're just putting like a scenario here. It might not exactly be. Thank you. It might not exactly be what it is, because for me, if I have to tell you how our modern day application is, I will not follow this, because sometimes the last, maybe the second to the last, maybe the fourth or fifth one should be the select withdraw. I don't know. So, or it depends, Sha. So, but here on the paper, let's just assume that this is the way it works. Insert ATM card, you enter your PIN, you select withdraw, you enter amount, and of course, you wait to do sharing, the money come out, and you carry it. Sometimes, I don't know your location, might get receipt, sometimes you might not get it, but at least you get your receipt in your email that, at a point in time, you went to so ATM to get your money. And this is the main flow. Then in an invalid flow, where it is not, is inconsequential, you would find out that the invalid PIN will, if you put an invalid PIN, it's supposed to show you error and allow retry. If you have insufficient funds, it's supposed to show you error also and you try. But if you try a wrong PIN 3 times, of course, your card is supposed to get blocked. At any point in time, if these 3 things happen and you don't get an error, you don't get your card blocked, there's no anything that is speaking to say that, oh, this thing is happening on your card or at the moment, why these events are going on, then it's the test did not pass, then there's a bug in that ATM. It must show, if you have an invalid PIN, the system is supposed to alert you that, oh, you have an invalid PIN. And also the messages should be clear to say that, okay, it's an invalid PIN, then you should try. Now, remember that that's invalid PIN. You are not allowed to try it more than, if you try it more than 3 times and your card is still not blocked, then there's a problem. There's a bug somewhere, because it means that you can't say you are the owner of a card and you are trying the card for 3 good times and you can't have access. Sometimes they don't even release the card to you. Just the system just swallows it and you can't use that card again. So that's for use case testing. Yeah. So normally, we don't just test one part. We test the real user journey and what can go wrong. And that's why I'm focusing on this part, this invalid PIN card, inputting invalid PIN like 3 more times, or insufficient funds. You don't have any money, but you keep on trying. You want to bypass the system. You want to bypass the ATM. Then there's a problem. So let me see what we have next here. So I think this is just talking about the withdrawal, the user. You can see withdrawal form, balance inquiry, balance transfer, the actions that a user can do, just like a real user journey. What happens from the point A or point B or point A to point J of what happened on an application or on an event that you're supposed to do on a software on an application. So that's for use case testing. And that can also happen too on, what do they call it? Sorry, that can also happen too on POS rather, or even we can use that also in a payment gateway transfer and all that. So now let's look at what we have on for the, okay, so for, sorry, I think I've skipped. Okay, we have queues with 3 on this. So we have state transition. Which of the following is an invalid transition for an ATM? Please let me know if you can see my screen. I do. Is an invalid transition. Which of the following is an invalid transition?
D.
Invalid transition. Oh yeah, oh, people should bring your answer. Oh.
Invalid. Should be D, or C or D.
D.
That person that is saying C or D. I will take it to who wants to be a millionaire. Stay in one place. Which one? C, which one? Are you taking C or you're taking D? Just stay in
Okay,
one place.
I'll go with D.
Okay, your final answer. Final answer. You want to call home? You want to call a
Final
friend?
answer D.
It's D.
Okay. So the other is D. Not sure. So the final is D. Okay, because okay. So that's that, because you a pin entered and
Card dispensed out.
wait to no pin entered, cash dispensed without validation. I don't know what. You know, cash dispensed without validation. Oh yeah, without giving you cash, right? Wait,
No,
and
card
this
dispense
is not
without
even a
asking
right
you how
transition.
much.
This is not a right transition,
No, I
because
think
if you enter your pin, you have not put anything there. If after you have entered, that's the transition. But
You
from
said
pin entered,
invalid. Is invalid transition?
it says invalid. You said invalid. You said invalid transition.
okay.
So when you enter a
Okay.
PIN, the next thing you're supposed to do is to take you to either what bank
Yes, I
account type
agree. Okay,
you're using,
yeah,
and
invalid.
all that.
Sorry,
So, but this one is invalid.
yeah, because from a enter, just want to. So decision table, a system gives a 10% discount. Okay, so this is decision table. The system gives a 10% discount if the user is a member or the purchase is above $100. A system gives a 10% discount if the user is a member. It's either you're a member or your purchase is above $100. Which conditions must appear in the decision table?
A.
Yeah.
A.
Somebody has
A is the
something else,
answer.
like some other, yeah. Okay. Think we have done well. So basically, quick summary is to say that software technique simply means focusing on this software test, this testing technique, so that we don't have all this decision table, state transition, use case testing, EP, that's equivalence partitioning, boundary value analysis. Those 5 are things that will help you at test designs that will help you to at least kickstart your test case. You don't need to like be able to now sit down all day and start cracking. At least you are, at least for the first time, you have like few test cases at hand, especially when you have a lot of input or a lot of combinations of data to deal with. So that's basically and all of these test designs or test techniques design that I've talked about are under black box testing. So I think that brings us to the end of today's class. So can we have thank you for, and I hope you learned one or two today, and I hope you enjoyed the class. And we can start having the questions and answer coming in now. Let me come back to the screen so that I know thank you.
Yes, well, thank you.
Thank you, Olusola. It was quite an insightful session. Please, you can start dropping your questions. Just do so by raising your hand. All right, I can see Ayotunde and Chinedu. Ayotunde, you can go in.
Good afternoon. Thank you very much for the class. Please, can you go over the decision table once again?
Okay. Okay, we'll do that. Okay, let me know if we are there again. Let me go back to, I think this is where we are. Okay, so you want me to go through it over again, right? Or you want to add something? Ask a question there.
I just want to go over it again.
Okay, so yeah, I'll do that. So decision table, I explained that the decision table is just a table that helps us to test all possible combination of inputs and their expected results. And I said that in this scenario, we are testing about if I put this and this together and they are correct, what is the system deciding? What is the system concluding to give, as in what is the answer that the system is giving to say, okay, if you combine this input or this data, what is the system response to this? Do you understand? So if we have, let's say, okay, we take we use this login required, because login is just, imagine that you have just your phone or you want to log in into your child deck or your health application, just your normal application. Just imagine that, right? So if you have that, and all of us know here that you already have a username that is unique to yourself. You also have a password that is unique for yourself. Now, the system is going to understand that, oh, you have combined some two conditions or some two data to say, okay, this person has provided their username. So the system is checking, is this username, is this something we have seen before? Is this something that we can relate to before? Okay, this username, I know it. Sorry, please, who even asked the question? I can't remember. Oh, this is your username. Chakam, they save it. Oh yeah, put password. The system asks, you put the password, and system looks around and says, okay, yes, this is usually the password that comes with this username. What the system we are saying is that because you have triggered that username, the correct username and the password, the correct password, the system understands it. The system makes the decision and action need to give a result.
Okay. All right.
System action need to give it a result. So the system already understand that, oh, I'm getting a username that is okay, that is valid, that is correct. The system also understand that this password that is coming with this username is also, the one that is not one data. We have two input condition. So the system now, if you decide one day that, oh, maybe you have dementia or you just decide to want to play around that, oh, I did not remember my password again, or I don't want my username. Let me just choose one other username I saw that is beautiful on Instagram, and you put it there. Then you now put your correct password. The system will also understand that this thing is strange. It's strange. I've never seen this thing before. The password might even look, but we don't even know if it's the person that owns this password. That's why we even tell you that either the username or the password is incorrect. So it will not give you access to that system, because the expected result is not what you will get. The expected result that you will get, right, is the error that you get, that the system will return back to you, because the system does not understand the combination of what you have put, the conditions you have put, the input data you have put is not something that the system understands. The system cannot make a decision, a successful decision for you with that. It will give you an error to say, okay, so this is the expected result. The expected result here will be that it is error. It will throw you error. It will bounce you out. It will tell you the different kind of error that you want to see. Now, in a case that, oh, you have the right username, but you said that maybe you woke up one day and you just, there are times that when you change your password and you don't write it down, you have so many passwords. As for testers, we used to have so many passwords. Then you now decide to now want to use your password, even though it's your username. The system might not even understand that it's your username. But if that your password is not your own, it's not something you have been using, maybe you misplaced it, or the system will tell you, no, we still do not understand you. You don't know what you're talking about. It will, the expected result that is also to bounce you out, to restrict your access to that application. So those your inputs, your combination of inputs or combination of data that you're putting into the system, right, is what will give the decision that table that will make. And why we are using this decision table is for you to now bring it out. Decision table is just to help you to bring out all the possible things that will happen, all the possible combination of input that can happen while you are logging in or while you are accessing the application. The possible things, all the possible things that can happen. And that's also the reason why, aside these ones I have here, because here we also have username that is no. That means it's incorrect username, incorrect password. The two of them is one deaf and one lame person. So it's with the name no. And I said another input here that could also happen here, possible combination that I still thought about is that even when you go to the system and you leave the username blank because you want to perform miracle. Sorry, miracle, that I'm using your word, your name. You go to password, you leave it blank, but in your benevolence of heart, you still want to click login. The system still will tell you that you have not made any action, or you have not, it will still tell you error. Those are, so we are just trying to bring out the possible combinations of things that will happen while logging in. Possible situation of things when you are making payments. Decision table. So this decision table is just to say how, and from here now, you can, of course, you are also able to carve out your test cases from here. To say, okay, validate that when you have a valid username and a valid password, the system grants you access to the application. Validate that when a username is valid and a password is invalid, the system restricts access to the application. Validate that when a username is invalid and a password is valid, the system restricts access to the application. Validate that when a system when you input a invalid username and invalid password, the system should also restrict you or even nullify your action at that point. Those are possible scenarios that you can bring out of it, and it's called decision table. Just the table is just for you to bring out the combination of possible combination of scenarios or conditions that can happen while doing an event on a requirement, while testing a particular requirement or an event. So I don't know if that. So we now went ahead. We now went ahead to use this. That's why we also came here to use this decision table. And we said that this is a decision table now. This decision table, don't forget that the essence of all this decision table test design is just for us to be able to create our own test case in smart ways. Don't necessarily have to wait and say, how am I going to test this one now? You people are giving me that, oh, if somebody is married, somebody is good student, they will get discount. It kind of look confusing to you, like, how do I test this now? So the decision table is saying, don't worry, I will help you. Draw your table. What is the condition? You put it married, good students. What is the action that will happen that when anyone, you put discounts here? Now, what is the rule? The rule is that if you are, rule 1 is saying that's the first test case. If you are a married person and you are a good student, we should automatically give you a 60% discount. That's test case number 1. Test case number 2 will be that, oh, you are married, though. If you are married, very that if a person is married and they are not a good student, they should get 25% discount. You write the test case, that's test case number 2. The same for rule 3, rule 4. So it's just a table to bring out all the possible, remember, possible combination of inputs that, that can happen in an occurrence, in an event, while or scenarios while you are creating that your test case. So these things now are the things you now maybe carve out to start writing your test case.
All right. Thank you very much, ma'am.
Yeah, you're welcome.
It's perfectly understood.
Yeah. So I know. Okay, I have a couple of people up who spoke before. Okay, I know the person I'm talking. Okay, Theophilus, can we have? I don't know who raised the hand.
Okay.
So hot.
Okay, good afternoon, and thank you, ma, for the session. So, quick one. There was a question on equivalent partition that from 1 to 99. So the person
Okay,
does, yeah, I want you to go back to the question.
Let's go there. Equivalent partitioning, right? Is it the question or the
question.
So when we get it, let's start. I think this is where it starts. So let me know.
Okay.
This one.
No, not this one. Yeah, this one.
Okay.
Okay, so the correct answer was A. I just want to know because I was actually looking at it if B also can be the answer. So I'm not getting this part correctly. So I'm there too.
Okay, thank you.
Thank you. Yeah.
So yeah, now. So here now, this question says that a system accepts input values from 1 to 99, which is the best set of equivalence partition. Remember that we said that equivalence partition is grouping or classifying your data or your input in the same category. Instead of you having to test from 1 to 99, no. We are saying that you can group them, you can classify them in a way that you can also test. You are able to test them, and you are able to cover you are able to get the right test coverage for them. And the reason why we're taking value A is because, like I said that testing is not just about testing the positive side. It's not just about testing the only positive. If you look at B now, B has values 1 to 50, then values 51 to 99. B is just talking about the positive side of things, the happy part, the sweet part. If I put this key and open this door, it will open. That's all. B is not trying to see, okay, if I take another key and come and open this door, will it open it? Will it lock it? Remember, I said that you are not just a tester to test the happy part, to test the requirement. Yes, we are here to see that the requirement meets the standard. It meets what is expected to be. But also, we are also here majorly to break application, to test and break applications. And if you are testing to break application, you are looking at the negatives, you are looking at the edge cases, you are looking at the things that are not normal that people can do. Now, so for hey, yeah, now you can see this one here now, less than 1. Is it part of the things that they ask them to do? No. So we are checking there. Then value for greater than 99. Greater than 99. Is it part of it? No. The only thing that is part of it is a value 1 to 99. This person already put these things in class. So the class is that anything less than the value that is less than 1, the value that is between 1 to 9, that is the group, the class. It has already partitioned this value 1 to 99 to a class. So anything in between this 1 to 99 is a valid and positive test case. Value greater than 99 is an invalid one, because anything over here is the negative. This between is the positive, is valid. All this value greater than 99 is invalid. Value less than 1 is invalid. Do you understand? So we are not all about, we are not doing this test case designs or test technique design because we just want to focus on the positive side. I explained over again that we are here to test to break. So the only thing you need to understand is that EP is talking about the groups, the classes, how you classify it. If you have like 1 to 1,000, you are able to classify it to say, okay, less than 1, less than 1 to maybe 500, 500 to 1,000, then value greater than 1,000. Of course, the value less than 1 and value greater than 1,000 would be an invalid test. But of course, you have done the work of equivalence partition. You have partitioned them into classes and into group. I hope this is clear. Do you understand now? Hello, can everybody hear me?
Yes, we can hear you.
So the person that asked the question, Theophilus, do you understand now, or is there still something that?
Yeah, I'm okay. I'm cool. Thank you.
Okay. So, okay, let me go back to the screen so that I know the person. Okay, now, please, if you know I've attended to, just put your hands down so that I can be able to see other people. Chinonzo, you can have the floor. I don't know.
Okay. Good afternoon. Thank you so much for a wonderful session. I really, really enjoyed myself while listening and learning. Okay. Okay. Let's go back to the boundary value analysis, the quiz. I think the first one, the first quiz.
Okay. This is the first one. This is the first one.
Okay, yes. This is. I know we chose A to be the answer.
Yes.
Right. I'm looking at E. What if I decide to go a step further? Say, okay, an edge case. Yes, I know the developers might know, okay, let them block the 0, which is a negative. I want to go a step further and I say, okay, let me do a -1. Will I still be wrong at that time? Or is it, am I overdoing it? Or I just wanted that clarity.
No, so thank you very much, Chinoso. So for this, E is actually not wrong. We are not overdoing it. So it's actually not wrong because we are still covering. Your test coverage is still apt. It's still intact because you are doing -1, 0, 1, 2. It still covers it. You understand? It still covers it because the reason why we took A more than E is because A already captured. Is 0 is like is 0, 0. You understand? 0 is so if you try to like put minus, you are still not wrong. So far that is capturing the boundaries and is also capturing the edge. the edges part of the boundary. So you are still in shape. Yeah.
Okay, thank you.
But just like you are overdoing, but there's nothing like overdoing testing. You
Yeah, I
understand?
just want to be sure.
Yeah.
I understand. But going by the book, sometimes it's not what we see on the real life
Yeah,
scenario.
exactly. Yeah, and that's where analytical thinking comes in for. Sorry. Hold on, please. Sorry, please. So, and that's where analytical thinking comes in for testers. You understand? When people say, "Oh, developers can do our job," and I just feel because nobody wants to have time and be thinking to say, "Okay, I've done 0. Let me take to 1." But because you are a tester, you can go out of your way to also. But the idea is that you understand what you are partitioning. You understand the boundary you are putting there. You understand your boundary value that you want to test. That's the main majority. So how far you are going to test or how is fact, you would also find bugs from there. So you are not doing anything bad here.
Thank you so much for that clarity. Thank you.
Okay, let me go back again to okay. So I have Frank Aikara. So let's have you, Frank. I'm so sorry, please. Theophilus, is there another Theophilus so that?
No, it's the same. I'm using.
Okay, you still want to talk? Okay, so Frank Ekara, please let's have you. So hold on, so that other people can have their time. So I will get back to you.
Good afternoon, ma'am.
Good afternoon, Frank.
Yeah, thank you for this a great teaching. Yeah, I have a question, and it will sound like funny question exactly. So I want to ask what's the difference between black box testing and software testing technique? Like black box testing technique and software testing technique. That's my question, ma'am.
So black box testing is a software testing techniques generally is I explained that is a part or is a type of way that we have secluded to aid our testing, to create our test case, a smarter way to work, a smarter way to work. Then the test designs are the ones that we have, are the types, the types of the software testing techniques are the black box and white box and all. Then those test case design under the types of now the test case designs under black box testing are the ones for EP, BVA, decision table, and all that. It's just like, let's say software testing comes first. Then under software testing techniques, we have the black box, white box, and all. Then under black box, because we are focused on black box today, under black box, we now have the text case designs that are boundary value analysis. We have equivalence partitioning, we have decision table, we have state transitioning, we have use case testing. Yeah. So do you understand? Thank you. Yeah, so miracle, the miracle working God. Miracle, we can have the floor.
All right. So my question is you almost somehow answered it, but then I still need to understand something. So from our last class, I think we thought functional, the types of testing, and now this is like the techniques. So will I be right to say that because you said white box testing, because I've been hearing this white box and then black box. So you said this white box testing has to do with it's like a coding type of testing technique. Why black box is like no code techniques. So integration testing, because the last class we were told that it has to integration testing like busy unit testing that developers are the ones to test. So they are under Yeah, they're under the white box because I'm just trying to separate them. So maybe all this functional testing, they are under the black box, or how do they?
Yeah, you
are
can
we?
say that functional testing are also part of black box. So we also have non-functional testing that tests that you also do that like performance testing and all that too. Now,
Yeah,
one thing I want you to understand again is I don't mix this up. You will find out at a
yeah,
point in this training that you get confused, but don't get confused. The levels of testing that you're talking about, integration system testing, is different from types of testing. Is also different. So now what we are talking about is the testing techniques. When they say that, oh, how you want to cook, let's say jollof rice, some people would mix their paste, put their rice, put everything and steam it. Some people would first fry, do even fry that. The first fry is techniques, how we do it, or ways to do these things to make it easy for you, to make it to make your test easy. Now, testing techniques that we talk about today is not types of testing or levels of testing, right? Now, even though you are testing, you still have to test functionally, you have to test non-functional, you have to do performance testing. And if you try to mumble everything up, you get really, really confused. And that's why also the host has made it easy to make sure that she differentiate them from different days. You understand? So we have even the type of testing, you're already mixing up with your levels of testing. And that one, people do it so much. That mistake, because if you're not careful, you like it's like interwoven, but you need to be able to know your types of testing and your level of testing and know what is under which. So, but black box testing techniques is what we are talking about. And we're talking about techniques is ways that you can write your test case or you can derive your test scenarios, ways you can do it, different ways you can do it. And that's why we have majorly spoken about the 5 major ways. And we are just saying that, you see, these 5 things that we have told you, like, is a way that you can design your test cases or your testing test cases, the way you can design it. These 5 is under black box. Yeah. So I think tomorrow, I don't know, I've not checked, we'll be talking about white box. So don't mix it together. Today was all about black box testing technique. And under it, we had the test case designs that we talked about, the BVA, EP, state transition and all of that, the use case and all. Does that answer your question, Miracle? Can anyone hear me?
Yes, we can hear you.
I think Miracle's network is sure. Okay. I think that's all for. Is there another question? If there is none, Miracle's hand is still up. I don't know. I can't. I don't know if she heard us. So I would hand over to the hosts. I think we're done for today. Please, can everybody hear me? I'm not sure people are still hearing me.
Yeah, we can hear you loud and clear.
We can hear
Okay.
you. We can hear you. We are very much with you.
Okay, thank you. Thank you. Okay. So in the aspect of none, we can have a good day and we'll meet again tomorrow.
Thank you very much.
Thank
Yeah.
you. Bye-bye.
Thank you.
Thank you, everyone.
Can we have access to the slide, man?
Yes, the host will. I think will get it on the YouTube, or so she would announce that how you get
All right.
it here.
Thank you.
It's a recorded session.
Okay.